So for this first example, we have 2x squared plus 8x equals 0, and we want to solve the equation. And so we know from our steps, our first step is to make sure that all terms are on one side, so it's set equal to 0. And I see that is the case here, it is equal to 0. So I can go to step 2, and that step says I need to factor this. So I first need to figure out how am I going to factor this. So first step always is to look for a GCF. And I see that here I have a GCF of 2 because 2 goes into 2 and 8 goes into 2. And then looking at my x's, I see that I can take out 1 x. They both share 1 x. And so doing that, I have 2x on the left. 2 divided by 2, I just get 1. X squared divided by x, I get x. 8 divided by 2, I get 4. X divided by x just cancels out. Equal to 0. So it's tempting to go ahead and just divide 2x from everything and just have x plus 4 on this side. However, we can't do that because we'd be losing a solution, because I need this part here because that's going to be one of my solutions in this next step. And so in this next step, we want to set each of our factors equal to 0 like we did in our last notes. So that means I want to set 2x equal to 0 and x plus 4 equal to 0. And then I'm going to solve both of those equations. So if I divide 2 from both sides, I get x equals 0. If I subtract 4, then I get x equals negative 4. So my answers here are negative 4, 0. So if I did go ahead and divide 2x from everything and I just had x plus 4 equals 0, I'd only have my one solution here. So that's why we can't just divide x out from everything. Okay, looking at this next one, my first step is to move all my terms to one side, so it's set equal to 0. So that means I need to move my 15n. I would recommend going ahead and moving the 15n because you always want your n squared term or x squared term or whatever variables you used to be positive. So I'm going to subtract 15n from both sides. And I get 6n squared minus 15n is equal to 0. And then from here, I know I first want to find and see if there's a GCF. And I see this one I do because I know that 3 can go into 6 and 15. And I can also take an n out from both terms. And so when I do that, I have 3n times 6 divided by 3 is 2, n squared divided by n is n, minus 15 divided by 3 is 5, and my n's cancel. And then now I can go ahead and set each of those factors equal to 0. So again, the purpose of this solving by factoring is we want to get to this factored form so that we can go ahead and create those two equations. And I can only do that when it's two factors multiplied together equaling to 0. So I get that my first answer is n equals 0. And so my two answers are n equals 0 and 5/2. Okay, so looking at this next one, I have 9n squared minus 16 equals 0. First, I'm looking to see if there's a GCF. Between 9 and 16, the only thing that goes into both is 1, so there's no GCF there. And 16 doesn't have an n, so there's no GCF there either. So that means since there's two terms and there's a difference, this might be a difference of squares, since there's no GCF. So I want to see if I can rewrite this as something squared minus something squared is equal to 0. Well, I know there's going to be an n here, and then if I take the square root of 9, I get 3. And then the square root of 16, I get 4. So I do have a difference of squares here. So that means that my answer, or my factored form, is going to be in this format. And to fill that in, I just put in my two numbers that are being squared. And now from here, I can go ahead and solve both of those. So I have 3n plus 4 equals 0, 3n minus 4 equals 0, subtract 4, So n is equal to negative 4/3, and then n is equal to 4/3. So you'll see with those difference of squares, you'll end up with the same number at the end, but one's going to be positive and the other's going to be negative. Okay, and the last one for this video, we have 6n squared plus 3n minus 4n minus 2 is equal to 0. So here I have 4 terms, so that clues me in that I'm going to factor by grouping. And so factor by grouping, I'm going to take the first 2 terms and find its GCF, and then do the same thing with the second 2 terms. So GCF of 6 and 3, I have 3, and then they both share an n, so I'm going to be dividing out with 3n. 6 divided by 3, I get 2n. And then 3n divided by 3n, I have the same thing on top and bottom, so that's just going to be 1. And now I want to do the same thing with my second pairing here. And so my goal is I want this to match this 2n plus 1. And now since everything's positive here, I want this to end up being positive as well. So whenever your n term is negative, you're going to be taking out a negative GCF. So here, instead of just taking out 2, I'm going to take out a negative 2. Negative 4 divided by negative 2, I get positive 2n. Negative 2 divided by 2, negative 2, I get positive 1. So now these are both the same, so that means I can take my GCFs and put them in their own parentheses. So I have 3n minus 2, 2n plus 1 is equal to 0. And now we can go ahead and solve this. So I can set each factor equal to 0, so I have 3n minus 2 is equal to 0, 2n plus 1 equals 0. So I have n equals 2/3. And negative 1/2.